After the discovery of an electron by Thomson and the discovery of a proton by the gold foil experiment by Rutherford, there was need to find the existence of another particle called the neutron, which is the third subatomic particle. There are three subatomic particles: electrons, protons, and neutrons. What triggered the need to discover this third particle was a problem, an error in calculations. And this is the error. By this time of their discoveries, the hydrogen atom was found to have one proton. The helium atom was found to have two protons. Okay, those are the positively charged subatomic particles. So Thomson and friends decided to do a ratio of the number of protons of helium divided by the number of protons in hydrogen. Now, the protons are the ones that are heavier than electrons, so they should dictate the mass of these atoms. So we can say the mass of helium is due to the two protons. The mass of hydrogen is due to the one proton. So if you do 2p divided by 1p, the answer you get is 2. Okay. So the ratio of the mass of helium to the mass of hydrogen was found to be 2, which did not make sense because in reality, in real sense, the ratio of the mass of helium to the mass of hydrogen is 4. So you can see that the math here is not adding up. So that told them there must be something else adding to the mass of helium that is making the ratio to be 4, because hydrogen for sure has one proton. In fact, hydrogen has one proton and nothing else in the nucleus, just one proton. Okay? So there was need to find what is this that is making helium to have a mass of 4 while hydrogen just keeps it as 1 to give the ratio of 4 in actual sense. Okay? The ratio is not 2 as determined by mathematics. So currently we know that in the mass of 4 in helium, we do have 2 protons, so there's 2 more subatomic particles not accounted for in helium. What are those? That was the need to discover a neutron. So Becker and his friend, his German friend, they firstly did this radioactivity reaction where they used an alpha particle, which is just a helium with a mass of 4 and 2 protons, no neutrons, and used it to hit an atom of beryllium that has 4 protons and a mass of 9. This is a radioactive reaction, and for them, Becker and his friend, the two Germans, they discovered that a high energy radiation was released. Probably it was a gamma ray radiation. Gamma rays are very high energy, but they couldn't see how that will contribute to the mass of helium, because you are saying the mass of helium has to be 4 and the mass of hydrogen has to be 1 for us to really get this factual ratio of 4. Okay, so another scientist called Chadwick came in and said, okay guy, no problem, I'm gonna help you out. So in 1935, Chadwick won the Nobel Prize in Physics. Amongst other contributions, he helped to discover the neutron, and this is what Chadwick saw. He repeated the same experiment and found out that yes, high energy radiation is emitted, but alongside that, there's another particle that has a mass of 1. Okay, and with no protons. So no protons, 0p, but a mass of 1 on the superscript. Alongside that, carbon-12 was produced, a carbon with a mass of 12, and 6 protons was produced. So he called this other particle a neutron. He called it a neutron. It's neutral. Why? It has no protons. And of course, he has no electrons. Those two subatomic particles have charges. Protons are positive, electrons are negative. However, this neutron particle, this new particle has a mass of 1. And it was important for it to have a mass of 1 so that we conserve the mass. Remember that on the superscript, those are the mass numbers. So on the left side, I have 4 and 9. If you add it up, it gives you 13, right? On the right side, I have 1 and 12. You add it up, it gives you 13. So Chadwick was correct. This new particle has a mass of 1. Now at the bottom here, the subscript, those are number of protons. On the left side, you have 2 plus 4 gives you 6 protons. On the right side, you have 0 plus 6 gives you 6 protons. So everything is conserved left and right. And this is how the neutron was discovered. And that discovery helped to explain the mystery as to why the ratio of the mass of helium to hydrogen is not 2. It's 4. Now we can account for that and say, okay, that means that the helium must be having 2 protons, as known before, but also he has 2 other particles that will help to make a mass of 4. Okay? So these 2 other particles happens to be 2 neutrons, of which if you take your 2, multiply by 1, 2 times 1 is 2. So the mystery here is that helium also has 2 neutrons in the nucleus. So now we can conclude and say, okay, so the atom of an element has a nucleus. The nucleus has protons and neutrons. It's not necessarily that there will always be the same number of protons, same number of neutrons in the nucleus. Sometimes they are different. But for helium, if this was a helium, you'll have 2 protons and 2 neutrons in the nucleus. The subatomic particles, protons and neutrons, are found in the nucleus of an atom. Out here is where you'll have electrons. If this was a helium atom, but for the alpha particle, he does not have those electrons. He only has the protons and neutrons. Neutrons are neutral, which is why if you're talking about the alpha particle that does not have electrons outside, that means that your nucleus, which has 2 protons and 2 neutrons, it's going to have 2 positives and no charge for the neutrons because neutrons are neutral. So the nucleus is going to be having a charge of +2, and therefore an alpha particle itself is going to be positive. So we talked about the particles before in radioactivity. You now see how this correlates. Otherwise, if this was a helium atom, we're going to have matching number of electrons, which will be 2, which matches the number of protons to neutralize the 2 positives. So yeah, so now we know that electrons are outside the nucleus, protons are in the nucleus, neutrons are also in the nucleus. Protons and neutrons, when added up, they give you the mass number or atomic mass of an atom. That's how this was solved. Okay, so the 4 here comes from 2 protons and 2 neutrons in helium, and the 1 here comes from the 1 proton in hydrogen. You divide 4 divided by 1. Yeah, truly, that accounts for the experimental results of a ratio of 4, the mass of helium divided by the mass of hydrogen.